What do you say, Randy? We get the show on the road here?
Let's do it.
Welcome, everyone. And thank you for joining us from all corners of the globe for our presentation on smart traffic solutions. My name is Corey Brenner in Channel Marketing at DIGI International. And I'm honored to be on another video with our friends over at SAPPLY in Australia, New Zealand. It's actually 10 p.m. my local time zone, and I'm still happy to be here, which should definitely serve as a testament to the impact and innovative capabilities of our relationship with SAPPLY, as well as the Australia, New Zealand tech community. I'm joined by SAPPLY's Technical Account Manager, Randy De Silva, as well as DIGI's Public Sector Sales Director, Steve Mazer, for what promises to be a compelling conversation on smart city connectivity, implementation of traffic systems, and an overview of a case study where we connected over 14,000 traffic intersections, driving uptime to 99% through a cellular solution in New York City. The recording of this webinar will be made available in the weeks ahead, and there will be time to discuss questions at the end. So definitely please feel free to drop any inquiries in the Q&A tab, and we'll address them at the end of our conversation. There's a ton of great content to cover, so without any further ado, I'm happy to pass the mic over to DIGI's Public Sales Sector, Steve Mazer.
Hey, Corey, and thank you everyone for joining today's webinar. We're going to explore the technology and design of a high-performance and resilient network architecture in this first section. And we'll first review a couple of case studies where it's deployed today, one using SCATs and the other NTCIP. Along the way, we'll delve into cybersecurity, automation, redundancy, and integration. Through the agenda, first a quick short company overview, then case studies, network architecture, short product lineup, and then we'll take a look at some industry trends in connected vehicle, cybersecurity, and automation. Then Randy De Silva will introduce SAPPLY and take us through a few case studies. Okay, let's get started. For those of you new to DIGI, we are a communications equipment manufacturer based outside of Minneapolis and the state of Minnesota in northern US. Our expertise is in wireless communications, networks, and embedded systems. We design and build everything from tiny IoT embedded modules to large high-capacity 5G routers for transit. We also supply the tools and services to manage and secure networks so that our customers can focus on their missions. Next slide. Next slide, please. The next communications technology presented today is deployed in the transportation industry in many regions and cities, including Toronto, New York, Miami, and Detroit. The applications include a combination of intelligent transportation systems on state highways, bus and rail transit, and city and county traffic systems. We'll take a closer look at two case studies in the next slides. The first case study is Oakland County. It's a principal county of the Detroit metropolitan area. It's one of the fastest growing counties in the United States. The Road Commission of Oakland County, or RCOC, operates 1,600 signalized intersections using the SCAT system in Oakland County. When RCOC officials concluded in the mid-'80s that it was unlikely there would ever be enough money to make all the road improvements necessary to meet traffic demand, they began searching for alternatives to traditional road construction projects, and their search led them to Sydney, Australia, interestingly. That's where they discovered SCATs. It's been deployed in the county since 1991 and now principally runs over cellular communication. Next slide. Another case study is New York City. The city has deployed 14,000 traffic intersections with routers. It's a very large system. Traffic Management Center is based in Queens. The network achieves 4 nines availability using a dual cellular private network system between the cabinets and the TMC. The system also provides access to all traffic cameras, variable mesh signs, and vehicle detection devices. Key aspects of the network architecture are presented in the upcoming slides throughout this first section of the presentation. Also of interest, DOT deployed a large connected vehicle pilot using DSRC involving hundreds of intersections and thousands of vehicles. Its primary focus was on safety applications, which was part of the city's Vision Zero initiative, which relied on vehicle-to-vehicle infrastructure and infrastructure to pedestrian communications. CV requires a high-performance network which was achieved by prioritizing the CV messages over other data traffic using internet standard protocols for quality of service. We'll talk a bit more about that later. Next slide, please. So looking at network architecture, the objectives of a good network design are clear, right? You need high availability, high performance, and it needs to be scalable so that it can grow over time as demands on the network increase. The challenge is in more of the design. How do you actually do all of those key aspects, including the redundancy, security, automation, and the selected technology? We'll touch on each briefly in these slides. In this slide, it's really the anatomy of a traffic cabinet in an intersection. Within the traffic cabinet, there's a cellular router. There's a PoE switch there to connect cameras and power them. There's, of course, a traffic controller, right? That's the heart of the traffic cabinet. Also, in the case of the connected vehicle pilot, there's RSUs and also RFID readers that were traditionally used for traffic analysis throughout the city. On the right-hand side of the intersection diagram, you have the wide area network links. We'll delve into those in detail later. In some cases, there's fiber in this situation, not much. Primary communications run over a particular carrier, carrier A, and then secondary is carrier B as a redundant link. And then on the left, bottom left is also quite interesting, and the solution here shows what's happening for traffic analysis. There's a Wi-Fi interface in read-only mode that is capturing passerbys' MAC addresses, be it in vehicles or pedestrians or bicyclists. The Wi-Fi MAC address is anonymized and sent back to the traffic management system where they use it for traffic analysis as well as other applications. And the other unique bit here is the Bluetooth interface. If you haven't seen what's happening in our traffic world is more and more the IoT type devices, which are used for Vision Zero initiatives and other projects, tend to have Bluetooth interfaces. The manufacturers of those systems use it for their management interface. That becomes available then in an intersection where you can, in the least, you can see that a device is up and running and it's powered over time to interface to those devices using that management interface as a goal. Next slide. Quick slide on the cabinet, obviously, and how the deployment happens. As most systems are IP-based, at least on their WAN side, replacing that older system technology with a new system over cellular is quite easy in some ways, right? Other ways it's not, but you really use a scalpel approach where you come in, take out the old comm system and put in the new system, matching up the IP addresses. In the case of New York City, they have a unique digital serial identifier in every cabinet. It's read by the router. That ID then triggers the system to know exactly which configuration is used for this particular cabinet. It's downloaded, and the installation technician can then check for LEDs, check for VPN access, and then call back to the TMC to make sure everything is operational all the way through to the traffic controller. The next slide. The key part of the system, which is the key area for meeting 4 nines of availability, is shown here. And how it's done is probes are sent on all the available WANs. If fiber is there, a probe is sent once a minute, and then over other carriers once a minute. The IPsec VPN, the probe is sent every 15 seconds for a better resolution. The probe comes back, the measured latency is observed, or maybe the probe doesn't arrive at all. That's counted then as a lost packet. A couple of those, and it's time to switch the IPsec VPN to the next available link. Also, the measured latency with a threshold is used to determine that the link is faltering, right? It's not down completely, but something is degrading the performance of the link, and that too is a trigger for moving the IPsec VPN. So in this fashion, the system is kept operational. You get high availability, and the VPN also of key interest is does not just move right back to that previous link as where it was, right? There's a hysteresis involved where you make sure that link is up and running. It's got good performance. The probes are coming back in good time, and only then is the IPsec VPN moved back. Also, a key feature of this system is you can you can actually detect when the TMC is down, right? For repeated attempts, nothing's working, none of the probes are responding. Ping to the backup traffic management center is successful. Time to switch everything over to that backup traffic management center. So provides that redundancy and failover system-wide. Next slide. Key to these systems, of course, is security, and encryption is the key part of that. Generally, you run as high as you can. AES-256 is quite prevalent now. DH group 20 on the IPsec authentication, and then SHA-256 as a hash function. The system uses only industry standard protocols. Everyone appreciates open systems to be able to connect in other devices and systems at a later date. Within the DMZ network of the Traffic Management Center, there's a next generation firewall. There's an intrusion detection and protection system, and then also an authentication server, which is the subject of the next slide. So how do you authenticate, right? It's a key part of cybersecurity. You have to have good authentication. You don't want a rogue system being able to access the network, especially through a VPN. So authentication can sometimes be simple as pre-shared key, as one might run on their home office network, but pre-shared key doesn't scale. Imagine a cabinet being compromised. You'd have to change the keys on every other cabinet, right? That's not practical. So what's used is certificates. Certificates are widely deployed. They're robust and proven. You use them on your laptop when you run a VPN back to your home office, right? So it's widely used technology. There's a certificate authority that's based usually in the IT department of the municipality wherein the traffic system resides, and then within the TMC, you have what's called a SCEP server. SCEP is an acronym for Simple Certificate Enrollment Protocol. It's part of the Internet standards. It automates certificate management. There's a SCEP client out in the traffic cabinet. SCEP client, then once the system comes online, it requests a certificate. It's downloaded from the server. And then the SCEP protocol allows for certificate renewal, right, which is a key feature of this automation, because I'm sure you've heard of stories where systems go down because unexpectedly a certificate expires. Can't have that, and especially when you have thousands of systems, you need a really robust automated system for that. Also, it's easy to revoke a certificate, right, if it's thought that a cabinet has been compromised, and your system can continue to run while you investigate the incident. Next slide. Part of the architecture includes device management. This is showing an external device management platform running in a cloud operation. The cloud sometimes, well, often provides access to other applications, right, as these systems grow and add functionality, especially something like connected vehicle. There's other applications that need to be a part of that solution for it to provide the benefits expected. You can find those sometimes in a cloud architecture. Important part of this diagram shows that if that VPN connection goes down or the cloud goes down for some reason, the operational network is not impacted. It is still up and running. It doesn't need to have that connection for it to operate on its own. You do lose some efficiencies, of course, because you'd access individual routers by HTTPS or SSH, but that's fine, right? You can manage until that system comes back up and running. Another important aspect of this diagram is the operational data within the traffic system is not lost. It stays there, right? The only thing crossing that VPN connection is in one direction performance data, which is used in the dashboards of the platform, and then in the other direction, configurations as well as firmware are sent. So it stays purely on a management level, and you don't have any access to this traffic information. And an important part of this too is there's sometimes a thought that security is compromised when you're connecting a private system, as most traffic systems are, to a public cloud. And that is also addressed by the VPN connection. You run a private network within what's shown here, AWS. The private network is only using private IP. You never really you never use any public IP addresses in this solution. Next slide. Also, as an example, architecture, it's important to be able to provide connections to legacy systems. They might have key functionality, of course, in a traffic system, especially the traffic operations server, right, which is running all those traffic systems. So it's always good to be able to integrate in performance data from the communications network, for example, to be able to allow the operators to hover over a intersection and see what is the comm throughput, what is the signal level, right? Making that all operational with ease right from their consoles. Also, asset data can be cataloged in an inventory management system, as well as if you've got help with a managed service provider, they can now have access to the system, but through a secure API. So only limited functionality is available to that outside party. Next slide. Quick two slides on product lineup, and then we're going to jump to industry trends. So looking at the management platform, we call it Digital Manager. This is a nice package for anything you might need to do on a network, such as firmware loads. We even allow third-party firmware loads to perhaps cell modules, right? That's a key part of the functionality of a network. You need to keep those firmwares up to date as well. Also, configurations, mass configuration updates. Some key features here is also being able to keep a copy of a system of a intersections configuration data. Should that router get replaced, it's a quick walk in, pull the old router, put the new router, and the system automatically knows that's been happening and it updates with that new configuration parameter. And also important, there's an on-prem version, so you can run the system in your own data center and under your own walls and inside your own network, right? It's the functionality is limited, but not in any way of what would really key need for your system, right? Some of the automation is not there, but all the key functionality is available. Next slide. And this is really a table of available routers from DIGI from A to Z for traffic systems and ITS systems, various price performance levels with a set of features. In the US, NEMA TS2 is the key specification for traffic. It's a high temperature range and shock and vibe. All products DIGI makes for this application are at that level of NEMA TS2. Just leaving this for reference. Next slide, please. Okay, let's look at some industry trends. And of course, the one that everyone's aware of is connected vehicle. And connected vehicle has been, next slide, please. A connected vehicle has been named our digital seatbelt. It's a key system, right? We all working hard toward it on a global basis. We know it's going to save lives, and in the U.S., the accident rates are only increasing. Something needs to be done. We know this is one great way to make things more safe, especially in our intersections. Dedicated short-range communication, DSRC, is proven, established. It's been around for a decade. It works great, and it's used especially in connected vehicle pilots, and also deployed in quite a few areas in the US, and I know Australia as well. The other method is called CV2X, or cellular vehicle to infrastructure, and that's where cellular devices communicate directly, right, to each other. There isn't a tower involved in that communication. It's called sidelink. That has been built into the 3GPP standards, was spec'd going back to 2020, I believe, and recently in the US at least, the FCC is leaning in toward CV2X instead of DSRC, interestingly. So more to come there, as this is an evolving trend here on connected vehicle, but we're all working hard to get there. Next slide. The cybersecurity threat landscape, very interesting situation, right? As operational systems are connecting into IT systems, they're getting the benefit, right, of the IT automations and system information. However, those older systems, some with legacy devices, are now exposed to what are IT-based attacks, right? And there, it's a more pervasive around the world attack system. There's been issues, right? We've had a few in the US where OT systems have been compromised by through access of their new IT-based infrastructure. So some of the key things there for that sort of system is that they're increasingly targeted by these information technology-based attacks. And it's very difficult, but we're doing quite a bit, right? And especially in traffic systems, at least certainly the ones that we've been working with, they're very tight with security and their procedures and their personnel. Next slide. And finally, automated network operation. A few years ago, Juniper Networks did a survey, and they found that the #1 driver of automation is security, interestingly. Number 2 is actually improving network resilience. Number 3 is reducing hard and repetitive work. So in summary, automation improves security, availability, and the operational efficiency of a network. One objective is to prevent avoidable service degradation events. Unfortunately, a frequently cited stigma is human error. We're usually at fault, hence the need to reduce hard and repetitive work so we can take ourselves out of that challenge. And another key area is QoS, right? And QoS, perhaps a term that isn't familiar to most, but in TCP/IP, inside the IP header, there's a field called differentiated services. In that field, if certain values indicate that a packet is a very high priority versus no priority. And by implementing QoS inside your network, should there be an attack, perhaps a denial of service attack, and your network's flooded with packets, IP packets, then at least those systems you've deemed critical, that they are providing high security, they need high performance deliveries, then those packets are always going ahead of all the other packets in the queues, inside routers, inside switches, and your network will stay up despite the denial of service attack. And so automation enables reliability, and reliability leads to predictability, and predictability is an important part of a modern information security. So it should come as no surprise that the more comfortable organizations become with automation, the more important security becomes as a motivator for further automation. And with that, I would like to turn it over to Randy, who, as Corey says, represents our strategic partner, SAPPLY, for Australia and New Zealand.
Thanks, Steve. I appreciate that. That was fantastic. I'm sure there's a lot of information, and I can see some questions already coming in. So that's awesome. And thank you, everyone else, for joining us today. It's great to have you. Most of you that are joining us today are familiar with SAPPLY and what we do, but I'd like to give a quick introduction of SAPPLY to the new faces in the room. SAPPLY have been around for over 15 years, at first focusing on enterprise and data center networking solutions. But for more than 5 of those years, we have worked with DIGI International and their best-in-breed cellular routers, making a strategic decision to focus on intelligent transport systems. What has become apparent is the sheer magnitude and complexity of deployments within the roads and traffic industry, and how crucial it is to support these critical projects to the best of our ability. And over the years, we've organically built a reliable team of technical networking and RF specialists, project managers, and a solid provisioning team to support the delivery of large-scale ITS deployments. At SAPPLY, we strive to align ourselves with our clients' objectives. And as you can see from this extract of the National Road Safety Strategy of 2021 to 2030, the theme is all about safe roads, road use, and vehicles, with a target to reduce fatalities by 50% and serious injuries by 30% by 2030. And that's just 6 years away. From the blue enabling action section, you can see a large component of this revolves around measurements, data, connectivity, and analysis. We're already 4 years into a decade-long plan, and I think we can all see a shift in the industry towards big data collection as a mechanism to make our roads safer. We've seen a significant increase in data collecting assets deployed in the ITS environment, such as vehicle detectors, counters, pedestrian detectors, and CCTV, just to name a few. DIGI's impressive portfolio of industrial cellular routers serve as the connection method for all these assets out in the field, alleviating any constraints from a wide infrastructure and networking point of view. The challenge is creating a tailor-made, consistent, and scalable solution that is repeatable over the course of these long-term deployments, regardless of the network architecture or type of edge asset that requires connectivity. And that's where I'd like to think SAPPLY comes in. So we've encountered a wide range of ITS projects, but our experience has taught us this type of product in these types of deployments is not plug and play or off the shelf in any way. At Supply, we prefer to tailor custom solutions with an application to support or a problem to solve in mind. Reverse engineering the ideal outcome to create tangible milestones with functionality and security is the primary focus. Once the solution has been agreed upon, we commence with type approval processes and ensure appropriate accessories are qualified as part of the deployment. We try to minimize risk by working with the client to create repeatable and scalable processes and documentation that provide a consistent and secure config profile for the application's connectivity requirements. Now, after seeing the impact of the global component shortage, we have all learned a hard lesson in planning, which Supply has really invested in. Taking the client's delivery schedule into account, we plan manufacturing and delivery with DIGI quite closely, making sure to include buffer stock to be held locally so that we can virtually eliminate any risk of delays to project deployments. When it times to actually deliver on the solution, Supply have processes in place to provide inventory records, firmware and config control, and remote support so that gateway for data collection becomes a plug-and-play asset for the client. Beyond this, we support and back our contribution with a flexible approach to review and revise processes and continuously improve on the overall solution. So we're just going to round this off with a few local examples of some of the projects that we've had to undergo. And obviously a hot topic in recent times is the 3G shutdown that's occurring with the 3 major carriers in Australia. Vodafone have already shut down their 3G infrastructure back in December last year. Telstra are scheduled for the end of June this year, while Optus are a little bit later in the year. I think December, if memory serves. We're committed to assisting our existing and new client base to upgrade their connectivity assets to be 4G LTE capable, and have done quite extensive work to ensure functionality is maintained over the course of this transition. And some of the experience we've had is that some systems have been out in the field for so long that there is little to no documentation on the inner workings, but we have been able to reverse engineer existing 3G solutions and identify specific application requirements that need to run on the new 4G device. With DIGI's built-in Python capabilities, we are able to script any custom functionality to replicate these systems and ensure a smooth upgrade path. This one in particular is my personal favorite, and I think will speak to a lot of you in the ITS space, especially from a maintenance perspective. It was reported that field techs would be going on site to address faults in a variety of ITS-related deployments with very little diagnostic information to guide and prepare them for what the fault may be. Without the ability to remotely fault find, it was observed that multiple visits were typically required, with longer delays in achieving a resolution to the fault. With that in mind, we set out to design an out-of-band management type architecture with the use of DIGI's iX30 that would allow techs to retrieve logs and fault codes from any manner of edge asset, either via serial or TCP/IP connectivity. Providing remote access enabled techs to prepare themselves for the site visit and therefore minimize return visits and expedite fault resolution. Lastly, this example really emphasizes the importance of specifying the correct accessories such as antennas and power supplies to complement a cellular deployment. Obviously, given the vast span of ITS deployments on Australian roads, signal strength can vary quite dramatically over distances and make all the difference. Supply set out to educate the stakeholders involved in these deployments on the importance of suitable signal strength, what parameters to look out for, and how to take readings off the devices in the field. Once they were able to identify when signal strength is the cause of poor performance, we went on to provide simple solutions to rectify any signal issues. Options such as selecting between standard and high gain antennas, and in worst case scenarios, opting for a directional antenna over the typical omnidirectional antenna for boosted signal and therefore connectivity. So to round it off, I'd like to take this opportunity to thank everyone that joined today's session. There's been a phenomenal response to today's webinar, especially with Easter long weekend just around the corner. And thank you to the folks in New Zealand. We know it's quite late over there. And to those of you in Western Australia, we know it's probably lunchtime for you as well. And it's been great to go through some of these fascinating case studies in associated network architecture, where cellular technology seems to be playing more of a vital role in the connectivity of edge assets in the field to the Transport Management Center, or TMC, as Steve refers to it as. It's clear that DIGI and SAPPLY have a strong track record in understanding and supporting smart traffic solutions for connected cities. And DIGI are committed to staying in touch with and preparing for evolving technologies to ensure best-in-class hardware, software, and security is available to ITS projects globally. SAPPLY and DIGI both have local technical resources, with DIGI's R&D offices right here in Brisbane, Australia, that are able to support development and delivery when required. And the SAPPLY team is your local conduit to DIGI International, and we pride ourselves on a customer-first approach across the Australia and New Zealand regions. We look forward to hopefully working with each and every one of you that has attended today. And I think now is as good a time as any for questions. So I'll hand it back over to you, Corey.
Awesome. Thanks so much, Randy. And thanks to everyone who's been pouring questions into the Q&A tab. Let's just get started in the order they were received. So first is, have you come across a gap in technical ability between the transport departments that build the full solution versus the feet on the ground that are responsible for deploying? And if so, how do you bridge that?
What do you reckon, Steve? Shall I take this one?
That's for you, Randy.
Oh, me. All right. So look, that's a really good question. It's quite a challenge, right? Because there are so many partners in play here, and more often than not, the people that put together these solutions, as the question was said, are not the people that actually end up implementing it. And it's difficult for, that transfer of knowledge that in an ideal world would happen, because not everyone's a network engineer, not everyone's an RF specialist. So I think one of the things that we've tried to do as an organization with DIGI as well is try and take the burden of these deployments off the feet on the ground. So, I mean, there's a lot of complexities with cellular routers, authentication, getting on the network, making sure you've got the right IP address, making sure you've got the right hardening profile as per the specs of that particular network and architecture. Some ports should be disabled, some ports should be enabled, some features should be encrypted, et cetera, et cetera. So our solve to that is actually taking on that burden and doing the config in-house, doing the provisioning on-house. We receive SIM cards from the departments, we receive config requirements and application settings from the feet on the ground saying, hey guys, I've got XYZ CCTVs or VMSs or FDSs going out on site, and this is our config, these are the site numbers. We do the site-specific config, get it all working, make sure it's commissioned on the network in our provisioning facilities before sending out to the contractors to effectively take it out on site. And it is, for all intents and purposes, a plug-and-play device by the time it reaches the contractors that do the work, do the hard yards.
Thanks, Randy. I know you guys talked a bit about some of the 5G portfolio. This may be a question for you, Steve. Could you talk about the expanding 5G options and if that'll include other product lines through combined LTE and 5G as well?
Oh, sure. We've transitioned more and more to 5G. Many of our products now are 5G. Of course, something that supports 5G also supports 4G, right? They never lose that, especially because of non-standalone. The 4G is actually needed. And even a number of them support 3G, right? So they cover the stack of technologies. More and more, of course, 5G is where systems are headed. Around the corner is something called RedCap. If you haven't heard, it stands for reduced capacity, where 5G is designed in these particular situations to address lower capacity, lower power applications, right? The 5G we're all familiar with today is high speed, right? High capacity systems. That's evolving too.
If I can just add to that, I will point out the iX40, I think, will be a favorite in this region. So it's just recently been released. It's still part of Digi's iX range, which is the industrial side of things. It's a nice little device with 4 Ethernet ports and SFPs. So with the use of VDSL SFP, for example, you could pretty much knock off every single connection option that's available in Australia. You've got fiber, you've got VDSL, you've got Ethernet. So if there's like an NBN handoff, via an Ethernet connection. You've got that covered, as well as cellular. And with the Linux capabilities that the Digis sort of show off, you can pretty much prioritize up to 5 or 6 different connections if you needed to, over the course of, you know, IP tables and weighted connections.
I just
I know
to add one more
Digi
thing too.
accelerated Linux. Oh, go ahead, Steve.
I just want to add one more thing. So I don't know if you know that there's an incredible number of LTE devices worldwide, just an incredible number. 5G devices aren't even close to that. So LTE is going to be around for quite some time. So if anyone's having concerns there. Sorry, go ahead, Corey.
I was going to piggyback off that question. I know just on Digi accelerated Linux is a hot topic as well. Could you talk about any options for running custom apps and scripts on Digi devices?
Sure, we have as edge computing has caught on, right? As more and more systems are involved in crunching lots of data, coming up with you know, answers and solutions at the edge, right? How do you do that? Do you have to have a compute capability on the device? Digi forever has had Python as part of its offering, and now last year, maybe the year before, we also now provide ability to load containers, run containers on Digi devices. So that's a whole nother new way to run as a virtual operating system within a Digi router, most any application you can think of.
Yeah, and that iX40 with the quad-core processor gives you all the sort of processing power and capability you need to run any sort of custom scripts or custom containers that are required for the application.
Obviously, big deployments such as, you know, New York City, throughout Australia, New Zealand as well, things, you know, are going to require some in-depth analysis and work with the current infrastructure. I think the question is, were there any technical challenges that you encountered when using your device for SCATs versus NTCP?
No, you know, SCATs originally was serial based, but over time it's now become IP based, and so SCATs messages, the formats are the same, evolved of course over time as all protocols do, but they're carried through the through all these networks using an IP based communication system. So it's very transparent. Oakland County in Michigan has been running SCATs for 30 years plus, and shifted to cellular about 10 years ago. So it's been quite a, and there's other systems too that I know of in the US that are all running SCAT. So it's quite universal now.
Definitely a big part of that is security as a utmost concern, I think, in all of these deployments as well. Is security as it works, if it's you know, especially with cellular routers as they're run through a private network, how is that security maintained when it's connected, when the connection point resides in a public cloud?
Oh yeah, let me take this. I touched on it earlier, but it's a great question, because too often the answer is thought that it's not possible, right? How do you protect a private network if you're connecting into a public cloud? But if you think back to when IPsec VPNs were invented, I can imagine many people wouldn't dare put their system traffic through a public network, right? But now everyone accepts IPsec VPNs as secure. Similar to a cloud, right? They have VPCs, right? They're virtual private clouds. They're quite secure. There's no public access to these private clouds, and you can access a public cloud via an IPsec VPN into the VPC of that instance and stay off the public internet completely. So no public IP addresses. It's secure and isolated from would-be hackers.
Yeah, and just to emphasize on that, with this architecture that, you know, Digi have put together, all the edge assets are not actually connecting to AWS. They're just connecting into the TMC via a proxy server. So the units themselves are told to send their Digi Remote Manager information to a proxy server, and it's just that proxy server going through that VPN connection that sends management traffic across to Digi Remote Manager. The actual OT traffic of edge assets, you know, your CCTV footage, your VMS messages, none of that touches DRM and vice versa. So it's just that two-way traffic, DRM to the edge assets via the proxy for any sort of config and firmware upgrades, auditing, compliance checks, that sort of thing. And the devices, the edge asset, the cellular connections going out to Digi Remote Manager to send health stats and things like that. But any sensitive information stays within your network.
A follow-up on that, I think, could you just on that same topic of security and privacy, how are personal MAC addresses anonymized? Does it really protect the individual's privacy?
So the way it's protected, and I believe it's actually an approved method in GDPR, but there's a one-way hash. It's a highly mathematical algorithm that takes the MAC address, transforms it into a unique number. The way it's structured, there is absolutely no way the unique number could be transferred back into the original MAC address. You can't do it, and it's just fine that way, because these systems who need a MAC address are looking just for a unique number, and the algorithm preserves that. The unique number is unique. A different MAC address running through the algorithm won't produce the same unique number. So it works just fine. Everyone's identities are protected, and these traffic systems can use the data for traffic analysis.
Do you have a way to prioritize traffic coming in and from the RSU to minimize latency?
I mentioned it earlier, QoS, quality service, internet standard, the best way to do it. It's been around for decades, and all you do is mark those packets with high priority in that DSCF field, and the whole system, not just the Digi router, but every router downstream treats that packet with priority, putting it in the front of queues wherever its destination route is set up to be. So it's proven. It's not used enough. I tell you, it really needs to be turned on, and it's a good way to make sure that things such as connected vehicle or the traffic controller packets and communications stay at the top of the performance curve.
You make it sound easy, Steve.
No, I don't know how to do it. Others do, but
That's a good note on support. Obviously, we have a great team and a lot of different people from support to the engineers kind of building the solutions themselves. Randy, you mentioned some of the teams kind of locally based in Australia and New Zealand. Could you talk a little bit more about the support network in place locally?
Yeah, absolutely. I mean, as I said, SAPPLY serves as a conduit for Digi, and Digi have a phenomenal base of engineers for their support. So it's not your typical, send through your problem and we'll escalate it to someone in 48 hours time. More or less, the person that receives that ticket will be the one that sees it through to the finish. We ensure that any ticket is addressed, and if it does need to be escalated, we've got local resources where we can escalate it. So Digi's resources in Brisbane are technically R&D and engineering. They're responsible for building all the wonderful pieces of hardware that come out of Digi. So they're not typically part of the support escalation path, but we always kind of leverage it if and when required. If it's something really funky going on, we can always ask for a bit of help.
So potentially on the topic of deployments and funky things of that nature, what are some of the recommendations for really large deployments? Are simulations recommended, for example?
Yeah, absolutely. I mean, if it's something that's never been done before, proof of concept is a no-brainer. So typically in the proof of concepts that we've done in the past, we'd start off with just 1 or 2 units on the test bench, prove the config, prove the functionality, test anything else that you might want to have a look at in terms of, disaster recovery, that sort of thing. And then take it into a slightly smaller sample in the field, maybe 20 to 50 units, test it out for 2 or 3 months, make sure there's nothing else that's, red flagged, something that's been missed during that test bench phase. And during that field trial is really when we sink our teeth into the actual logistics of the program. So let's say we're talking about a deployment of 5,000 units. That needs to be planned. There's quite a bit of intricacy in terms of, you know, scheduling hardware, scheduling provisioning, scheduling SIM cards, all of those pieces we try and be involved in and make sure that we provide a cohesive turnkey solution to the end client, with the cooperation of any other stakeholders that are involved, be it contractors with the work package, you know, maintenance teams, delivery teams, cybersecurity, etc.
You mentioned disaster recovery, which I know is a huge concern for especially city infrastructure. Do cellular networks used in the traffic system stay up when faced with overwhelming demand, such as, you know, a localized disaster?
Yeah, let me take this, Randy. I think, you know, especially just looking at New York City, right, to think that a mission critical system as such as that would run on a commercial cellular network 10 years ago, probably people would have thought you're nuts. But what's happened is the evolution of cellular, and it has a lot to do with what the demands are that folks need these systems for, but also 3GPP, who's designed the system, who specifies it on a global basis. And 10 years ago, they put into the network architecture the ability to do priority and preemption. But that's a specification. It was a challenge, right, in its design and deployment. It's now prevalent in all major cellular networks. You can pay a little more, but you get, right, priority and preemption. And in places like New York, you can imagine, right, it's quite frequent when the network becomes loaded in certain regions, the traffic system stays up just fine because every traffic cabinet gets priority over typical cellular users in the network. So it works great. That's why cellular is on a climb, right, to take over a lot of networks.
And just to speak to that in terms of New York City specific deployment, I think what's fantastic is the dual cellular module. It's not just dual SIM, it's dual cellular module. So you've got two carriers constantly dialed in. And so if one carrier decides to unplug a core switch, for example, there's automatic failover onto that other carrier. So I think that lends itself to a lot of robustness that could be leveraged.
Randy, I loved hearing a lot of the history, sort of where we are, you know, a decade ago with the evolution of cellular to where we are today and where we are tomorrow as well, kind of looking at the future of connectivity. Do you think there's a role for cellular for traffic systems that are primarily connected by fiber at the intersection?
Yeah, look, I think so. Running fiber is not cheap. Yeah, I mean, you got to dig up the road. You got to, you know, plan for that. There's got to be capacity in the conduit, and sometimes you just don't have that luxury. So with cellular becoming more and more prevalent and more like society is becoming dependent on it, let's face it. And with 5G just around the corner, I mean, it's already being deployed. 4G is, you know, in its sort of, I guess, at the peak of its deployments. I don't see it going away anytime soon. Steve, thoughts?
Yeah, and just one important aspect to that is in our discussions with various cities who have fiber deployments predominantly, when there's a fiber cut, it's a fire drill, right? All hands on the site because the corridor is down, and that's very costly and disruptive to people and to the system and to the users, right, of the traffic system. So fiber is great. Put a cellular backup in there, right, just in case. So when there is a break, then no one has to run and get the trucks and go fix that fiber, right? It's system's up. You got some time. You can fix it over time. It just makes for a better system operations.
Can you talk about some of the collaborations as well? Obviously, with city infrastructure and the departments of transportation, there's a lot of different back and forth. What were some of the different engagements with the New York City Department of Transportation when?
Sure. You know, it's going back 3 years, but just, you know, early on, right, there's a specification. How do you actually design something to that? There's a lot of correspondence and working with engineers at DIGI and engineers at the DOT to find the right solution. And then as it evolves, right, it's a never-ending process. But it was definitely collaborative. And in that, we've all benefited as our equipment and technology at DIGI's improved. It's become tailored now for traffic systems because of that huge network. Yeah.
I think that's something that's so important, Stephen. Randy mentioned just kind of the feet on the ground and the local experts as well. I think it's one thing to have, you know, the engineers, the sort of brilliant mind in the sky type of roles, but you really need to have the local understanding, whether it's in, you know, Brisbane, Sydney, New York City, wherever, to have that local support. And I think that's something that Randy touched on as well, to kind of have those local industry experts as well as the people who are kind of there to answer the everyday questions. Speaking of
Yeah,
everyday
exactly.
questions, we're sort of at the end of the questions coming in live. So happy to take maybe one more in Q&A. Otherwise, we can wrap things up.
I suppose while we're waiting, what I will say is, I mean, feet on the ground versus that sort of head in the sky engineer level knowledge base. It's impossible to transfer everything from the person that's designed a solution through to the person that's in front of a cabinet trying to plug everything in and get it all working. But I do think education is a big piece of that. There's obviously, you've got to be realistic and practical with what education and what the audience is. You know, you don't need to be teaching the full TCP IP stack to someone that's about to commission a router, but just general principles of what needs to be done, how things need to look. Simple things as well, like using a MIMO antenna in 4G rather than a SISO. It's incredible how much of a big difference minor details like that make to the success of a deployment. And the better educated everyone is, the more successful these things tend to be.
Agreed.
Absolutely. Teamwork. I think
That's
this
it.
may be our last question. Could you talk a little bit about the involvement of cellular carriers, whether it's to you know, private networks or deployment and coverage in certain areas, and just the relationship with carriers and some of these initiatives?
Cool. Steve, do you want to take that one?
Yes, let's see. Carrier, yeah, we work with carriers. We partner with carriers. It's of course key to the solutions, right, of cellular, and you know, so it's also evolving and much appreciated. So we generally, I don't work too much outside of North America, but it's a key part of our solutions and our partnership, right? Working with carriers, and as their networks evolve, we evolve with them to deploy these solutions for our customers. So we all benefit from that.
Yeah, even from a local point of view, it's it's kind of a no-brainer, really. The cellular routers won't work without a carrier in place, but I guess from a dynamic point of view, you need to almost have this three-point system where you've got the client that's effectively going to be taking the service from the carrier, and the vendor as well. And if any one of those parties is out of line, out of whack, it's just not going to be cohesive. So it's not just about the client and the carrier having conversations and the manufacturer does its thing on the side, and vice versa. Everyone kind of needs to be on the same page. And did you do that, I think, quite well in terms of staying in touch with the latest changes that are happening with local carriers and any patches that need to be created. You know, DIGI's Brisbane office releases a firmware update every quarter with any major releases, any security upgrades, any severe security vulnerabilities that are identified during that quarter will be released in a patch. So any network changes from the carrier's point of view needs to be considered when these upgrades are being built. And so, yeah, kudos to Digi on that front in terms of keeping up with everything that's going on.
From the
Well, it's
tech to
definitely a
even
partnership.
Yeah.
right down to the language and the logos even, I get messages from major carriers if any brand guidelines shift or anything. So I know that's a big thing we really pride ourselves on is playing well with others and making sure that we're in good step with the carriers for sure as a key part of that equation. Well, we're at the end of our time. I think that's probably all we have for today. As we said, we'll send out this recording in the weeks ahead. Definitely thank you so much, Randy De Silva and Steve Mazer. For everyone, please feel free to reach out with follow-up questions and opportunities. And yeah, we look forward to seeing you next time.
Thanks, Corey. Thank you, everyone. Appreciate it.
Cheers.